I'm revisiting working on this old, from last year, phone line simulator using one of these slick modules to interface with the phone line, where I had integrated this onto a PCB using ESP-8266, and I had a prototype up and running, interfacing with a phone, hearing call progress, tones, detecting DTMF button presses, and so on. But I found I didn't really want to use ESP-8266. It ended up too limited. So I'm switching over to the ESP32 using one of these 30-pin modules, and I've taken the old ESP-8266 project files and I'm now continuing those on the ESP32. So here, this is an ESP32 just on a dev board PCB that I made a few months ago for easy access, hooking up GPIO. I have audio output wires going to this other PCB where I connect up an audio cable to this amplifier so I can hear what Mozzie is generating for sounds. And I have this second ESP32 just sitting on a breadboard, and that's because I'm simulating having two phone locations that are wirelessly talking to each other, getting ready to coordinate a phone connection. But I'm not that far ahead yet. What I wanted to do was strip down the features and start over just looking at Wi-Fi between these modules, because I want that to be a trunk line instead of, back on this board, I had RS-485 cables running between the two stations. I want to be able to just have one talk over ESP-NOW wirelessly to the other if it wants to place a call and find out, is this node busy or can it accept a call? And then it would make a phone line wire connection so the two phones can interact. So in the hardware folder on this temporary GitHub location I set up for the work in progress, all that I've really done is delete the ESP-8266 module and put the ESP32 in. So I have the audio output pin for Mozzie sound generation. And I've also got this configuration jumper now. This is new. We'll look at that. And the rest of this is really not yet changed. I have to figure out what GPIO I want to use for this ring indicator LED. And I'm still trying to decide if I need a hardware MT8870 chip-based method of detecting touch tone presses on the phone line, or if I want to just take the audio path into the module and try to use software to detect button presses. So that's to be determined. And now that the ESP32 has a lot more GPIO than the 8266, I may likely get rid of this GPIO expander I2C interface and just take the slick phone module directly over, or using buffers, to the module. So in software for now, I'm not controlling any relays to connect any phone lines. I don't have the slick module hooked up yet. I'm not detecting DTMF keys. All I'm really doing is looking at this jumper here to figure out if the node who's running software is going to be a master or a slave. And then I'm just taking Mozzie audio out to the amplifier for testing. Down in the sketch area, I just made some notes on this revision 1 folder. So here's all of the files currently in this project. And as I often do, I'm referring to Random Nerd Tutorials website for information on how to use the ESP32, what GPIO pins are safe to use as inputs or outputs, things like that. But I'm also starting out my project now based on this one here. So this uses ESP-NOW as well as creates a web server with Wi-Fi so that one of the modules will act more like a master and it will have a web server in it showing some data. And over ESP-NOW, it will communicate with another module that's not doing a web server, it's just sending some data over and receiving some data back. And in the end, for this phone line system, I want to send, instead of temperature and humidity back and forth between modules and throwing it up on this web server, I want to send information like node 1 wants to call the phone number over at node 2. So are you busy or able to take a call? And depending on what's going on, either connect the call or send a busy signal into the phone where the person is trying to make a call. Things like this, so I don't need wires physically running to communicate between those. And then, based on the status of each of the nodes, maybe that's the kind of info I would put on this web server. So just by following this project example, it necessitates one of the two modules being more like the master who's doing the web server. The other one's more like a slave, and having it set up this way, ESP-NOW does auto pairing, so I don't have to hard code MAC addresses and tell them exactly which module to look for. They can just figure it out between themselves. And otherwise, I do need a router so that this master web server module can connect to that, and then that's where we can access this internal web page. So I'm just using a spare router. I'm not connecting to my internet world facing router. It's just only within the house. So that's what this server sender jumper is all about. This GPIO is actually only an input on the module, and it does not have an internal pull-up. So I have an external pull-up to 3.3 volts, or I can install the jumper and short that input to ground. If this input is grounded, this module is going to act like a server, and if there's no jumper, so it's pulled high, it will act like the slave sender module. I only wanted one software to put in whatever module I want, and so I'm just using a jumper to make it easy, so that's how I can differentiate how I want this to run. So in my test setup, this module on the dev board is set up to be the server, and this other one is set up to be the sender. So right now, when I power up, this one is going to try to join my router. Then it's got its internal web server, and it will try to auto pair with this other module over ESP-NOW. And when everything's good, they'll both send data packets back and forth, and this one will update data on the web server. So in my project, similar to this internal web server, I've renamed mine as Telephone Central Office Dashboard, and this is the temperature and humidity. I just renamed it Hook Status and Ring Status, and it's just sending random data back and forth. I just wanted to make sure it works. So this top terminal is the serial port on the server, and the bottom one is the sender. So I'm going to hold both of those in reset, connect up. Now, if I first take the server out of reset, it joined my router. It's got this IP address, which is this internal web server, and nothing is updating because the other sender module is still in reset, so there's no data to go back and forth. So now if I take this out of reset, I will disconnect from both of these now just so we can look at what happened. It's still going to update. They're still running. I just turned off the serial port here. So the server, this one here, powered up, got onto the router. Eventually, when I took the other module out of reset, a pairing request from ESP-NOW came in and they paired up. Then packets started coming in and this data on the web server started updating. So down here, when I took that sender out of reset, it powered up and it identified the jumper is telling it to be a sender. So it's not trying to join any router or anything. It just immediately tries to auto pair with ESP-NOW, sending out a request wherever it can until it actually communicates. And then they started talking to each other. So now this temperature humidity data is just getting sent around. So if I connect again, of course now it reset the module, so it's joining Wi-Fi again. I'll refresh this web page here. So here we can see temperature and humidity 692 came in, or whatever the case. I can't remember if I'm generating those. It's not the same data that gets sent actually, but the point is 35 and 29. Okay, now 6 and 95 are the numbers getting updated on the web server. 15 and 26, and those are getting updated. So essentially, I'm able to communicate both directions with ESP-NOW and update info on this web server. Now, if I go down and look at the sketch as it is right now, the main file is this INO file, and the rest are headers or CPP. I also have this Arduino secrets header file to store, it's not showing here, the SSID and the password for Wi-Fi just to make it easier so it's not buried in one of the other files, and it's easy to distribute this on GitHub. I don't have to keep going in and changing it, uploading it to here, and then change it back to my actual info. So in the main project file, there's a lot of stuff just commented out because it's left over from the 8266, and also because I took out a bunch of features. So right now, I'm just doing barely what it takes to get set up and do this Wi-Fi stuff based on the random nerd tutorial. And in the main loop, all I'm doing is using Mozzie to test that I can generate call progress tones, but also I have this wave file playing the message, "This is a recording, hang up and try your call again." I did a previous video on that. So I'm just looping through all of the Mozzie tones or samples and then doing whatever I need to do based on if the module is a server or the module is a sender. I'll go and do the Wi-Fi or ESP-NOW related stuff and then just go back to letting Mozzie generate tones. And so if I turn on this amplifier, we can hear those tones going on.
Completed as dialed.
At the same time, all of this is communicating.
We're sorry. Your call cannot be completed as dialed.
And that's not the entire, this is a recording audio sample. I just cut it short for demoing it. So that's what I really wanted to be testing at this point. Starting over new with the ESP32, I could not play back audio samples like "this is a recording" on the ESP8266, which is one of the things that I saw as a limitation. So I wanted to test that and all the Wi-Fi stuff. I put functions in a separate file. So for the pre-recorded message, the audio data was converted into this array of numbers that just get played back as an audio file that we went through in the other video on that. And the main concern was it's probably resource intensive to be playing back an audio sample while doing Wi-Fi stuff, even though the ESP32 has 2 cores and one of them is mostly dedicating itself to Wi-Fi. I wanted to make sure I can do these 2 intense things before I even continue. So the next step, I'll be just reintroducing the original features, hooking up the actual Slick module, make sure it still can run, and then I'll get the state machine going and try to get all kinds of features implemented, including I want to get a rotary phone to have its pulse dialing detected, not just digital DTMF tone decoding, so I can place a call from an old rotary phone. But I have to go through this step by step and make sure everything stays working, and hopefully I don't break something along the way.